Hello everyone. Okay, let's get started. If anyone is there and can tell me if they can hear me, that would be really useful. If not, then let's just assume it's working and move on. This evening I would like to play around with a couple of projects that we've not played around with on stream yet because we've been basically focused on cosplay. So the first one that I'm going to look at is called Subplot. So I can introduce you to that. Subplot is a tool that I work on with a friend of mine, Lars Fitzenius, and it's a testing tool. And testing tools aren't always the sexiest or most fun things for people to work on, but they're incredibly important and incredibly useful. And the way that we do our work on Subplot is that every 2 weeks we have an iteration. It's a little bit like a sprint, and we have a number of tickets that we try to work through in that time. We don't always succeed, but sometimes we do. It's fun for us, and so what I thought I'd do is take you along on working through one of my tickets for this iteration. So the way that we do that is we have milestones in our project, and if I pull up our current iteration, then you can see what we've got left to do. And what I was thinking of tackling today is this issue, number 280. So I think to explain this better, I should show you Subplot running. So I'm going to pop over here and I'm going to run our test suite. Now, our test suite runs both Rust-based testing and also tests Subplot using Python. So once all of the Rust tests have completed, we will hopefully get to see some Python tests run. Here we go. So this is the Python test runner executing, and you can see that it says scenario blah, step blah, cleanup blah. We're getting a reasonable piece of text out whenever any step executes. And if we go ahead and look at the actual input to this thing, which is in subplot.md, then you can see, for example, with this scenario here, which is the no date anywhere scenario, we have all of this text, and this is useful. If, however, we ran that same scenario just under the Rust template, I'm not sure, are we done yet? There's a little bit more of /check left. Where are we at? That was files. We're still at daemon. Okay, so while that's executing, I'll explain a little more. Each of these is what we call a scenario step. So given file dateless.md is a scenario step. And Subplot works out what to do with that by looking for its bindings. And if I pull up the bindings for the files library, then we can see here given file blah. So given file dateless.md comes along, picks up this binding. Dateless.md is put into the embedded file variable, and in Python this is files created from embedded as a function name, and in Rust it picks it up from the subplot step library. And we have some type annotation here because obviously when you start to muck about with Rust you need types, and in fact the file type here tells Subplot a little bit about how to parse this embedded marker. You can also ask Subplot to parse things with regular expressions, in which case you get to just label stuff up like that. But in general, it's better to use this braced format and then tell Subplot what type you want, and that helps it to work out what's going on, and it gives a bit more semantic information to the parse. So our check is finished. So what I was thinking I would do is if I cargo test subplot, in fact, you can tell I've done this before. So if you run a test normally in a Rust test suite, even if it succeeds, you see nothing. But you can tell the test runner to dump a bunch of stuff out. And instead of this nice, neat sort of, scenario blah, step blah, blah, blah type messages, you get this big mess. So we get told, okay, scenario starts, no date anywhere. That's pretty close to the Python output, which is just scenario : blah. So we can probably change that pretty easily. But, context hooks returned okay. That's probably not a message that we particularly need to care about. Success messages, particularly for things that are internal to the execution of software, not really worth mucking about with. And then we get this step create from embedded, which is much less useful than seeing given file datelist.md. That's much more understandable to someone who's reading a log of what's going on, So we want to improve all of this text. These things like creating temporary rundir and so on, I'm quite happy if they come out for now. It's a bit noisier. The Python test runner has a separate log from its output display, but that's not really the way that you do things in Rust. So this big chunk here where we execute subplot and we get some information, that would go into the log file in the Python runner, but we may as well just output it here. And, clean up, uninstall subplot, clean up returned okay. Again, that's just not as nice as just seeing that kind of thing. And that would be the equivalent of, clean up, given an installed subplot. So realistically, we want to get all of that nice and neat and tidy and looking as similar as we possibly can to how the Python runner works. And the reason that we want to do that is just it's ugly, and it would be much nicer if it were the same. So this is the issue that we're going to try and tackle. This is issue 280. So I'm going to start by making a fix 280 branch. This is just my way of doing things. If at any point I gloss over something in Subplot that you'd like some more information about, then just say in chat, and I will try to accommodate. Okie dokie, let's have a look. So step one, let's find where we're outputting stuff. It's not going to be in the examples, it's not going to be in share, it's not going to be in the main subplot source, it's going to be in subplot lib. And it's probably somewhere in scenario for the most part. Here we go. Scenario run is going to output almost everything that we care about. So we say scenario start, the Python runner just says scenario. So let's just say that, nice and simple. Here, if the context hooks succeeded, we're saying context hooks returned okay, otherwise we say context hooks returned failure. So let's just be a little bit more circumspect here. If ret is error. Nice and simple. We're only going to output that message if we have an error. Next one, we want to output the step. In the Python code, that was done by saying space, step, space, and then the step. Now, we don't have everything to hand yet, but we can at least start to make things line up. And the problem at the moment is that the step's name is the function name, not the text that represents the step. Again, here we have something about context hooks. So let's say if ret is error, then context hooks return failure. We don't want to say run step function. We've already said the step that we're doing. Now, in the Python code, there is no that step succeeded message. And I think if the step is going to give an error, we're going to output the error anyway. So there's just no need for this message. So let's get rid of that. And then unwinding step contexts, we don't need. This is, if there's an error in a step, there's no point printing that out. Running cleanup functions, we don't need to print that out. Cleanup is just done, again, space, cleanup, space, and then the text. So let's do that. And again, at the moment, we're just getting the cleanup's name. There's not a lot we can do. And I think we just want to say, if res is error, the cleanup returned failure. And we'll worry about, you know, how many spaces and stars and other things we want later. Running scenario close down, not really necessary. Again, you know, the scenario is returning OK or failure. Well, the Python code doesn't say if there's an error or not. I mean, we could leave this one in for now, and we could go, I don't know, return colon. That's probably good enough and neat enough for now. So there's our first chunk of text being cleaned up. Let's see what that looks like when we run the No Date Anywhere test. This is starting to look a lot better. You know, scenario, step, step. This text, yeah, fair enough. It's not great. We could probably improve it and make sure that all of the debug output that happens while you're running a step is indented, but then again, having it right at the start is probably fairly obvious what's happening. And then return OK. And then that bit is actually out of the Rust test runner. But this isn't quite good enough because of this name. So let's just check that test there, and let's make a commit. We're going to say subplot lib make scenario run output a little closer to Python runner. So we've got that change in. The next thing that we want to do is we need to get the text of the step. Do we have that to hand? Let's see. Did I open? I didn't open the documentation. Cargo doc. We're going to have to wait a little moment or three while the documentation for Subplot builds. The reason I'm doing this is because obviously it's documented. Not necessarily brilliantly because things take time, but particularly we have subplot lib, and within that we have scenario step. Yeah, so this is the type that represents a scenario step within Subplot. And it can return the step's name, you can call the step function, we can create a new one. I think for every step in a scenario, its cleanup is actually passed as a separate step. I mean, we can check that. Let's pop into subplot lib scenario. Scenario. Add step. Yeah, we add the step that's going to execute and the optional cleanup step. So there's nothing special about a cleanup step. It's exactly the same shape. If any of the cleanup function's error, this will error exit immediately. So the problem that we have is obviously the step in question has to carry information about the arguments that we're going to give it. How do we do that? Well, we have a step builder, and that step builder returns a step object. So perhaps we could have that step builder type also take just the full text of the step that we're going to execute. That seems like a reasonable thing to do. It obviously doesn't currently, otherwise we'd have that information to hand. So let's pop back into step. That's that scenario step. Prelude. Do we have the builder in here? No. So the builder must be something different. So we're going to have to put the information into the scenario step object, since that's passed into the step library. So let's start with that. Let's get to step. New obviously just takes a name and the function, the registration. I have a feeling that this name is pretty much only ever called from that one place. So we could change that name. So instead of taking just a name in text, it takes the full string of the scenario step that's being executed. But let's just double check. Let's go to all of the references to that function. So render panic, we'll render it. And that says this step panicked in this way. I think that could benefit from having the full text as well. And then in scenario itself, we have printing the step out. We have prepping the step starts. and in that we say it's this step name, and that's passed to the scenario context hooks. And the reason that we do that is because you might want to say, hey, I'm preparing this context for this step. So again, we should pass the full description of the step in. That makes sense. And here, again, it's printing out the step during the scenario execute. So in all of these cases, this name function realistically should be the step text. So let's do that. Let's take this name variable and let's refactor it to be step text. There, we're going to have to do the same. We will refactor the function to be called step text. And instead of return the name of this step, we're going to return the full text of this step. So, step number 1, as it were, if you'll excuse the pun, is to refactor that to say, this is not just the name of the step, this is in fact the text of the step. Ooh, next we want to find some way of actually returning that. So at the moment, if we try to run that test, things are going to go horribly wrong. Yeah, okay, they didn't go horribly wrong. They didn't go horribly wrong because it's actually passed in as an argument like that. It's not we haven't changed the builder yet. The way that the builder works is that actually comes from subplot lib derive. And that's because the builder is part of the step functions themselves. So if we go and look at a step function in the step library, particularly the given a file name, which I think is, given file blah is create from embedded, and create from embedded defers to create from embedded with other name. Create from embedded with other name does all of this stuff, and that's fine. But this little step annotation here is creating a whole bunch of extra stuff, and that's done with a proc macro crate here called subplot lib derive. So let's work out where we need to make the change. So this is the builder stuff. Where is our builder created? Struct definition stuff. So struct builder is given a whole bunch of fields, and they're these fields that we create here, and then those fields pass down into other things. Like, what's the word I'm looking for? They pass into the arguments that we end up calling the step function with. So we need to do something here to get access to the name, effectively. But it's not just the name, though. It's the actual text of the step. Perhaps instead of doing it in the builder's fields, because then we'd have to change quite a lot of stuff in order to protect against that, it might be an idea to change the build function. So the build function takes self and currently uses the step name string, which is literally a string that we formatted out from step name, and step name is an ident that we've extracted and is literally the function name of the step. I think it's probably useful. Is it useful to know that, or would you just use a debugger? I think you'd probably just use a debugger. So realistically, what we want to do now is we want to not call step new with step name str. We want to call it with some extra string that gets passed in when we do the build. So we're going to say here that we want step text, which is a borrow stir, and we'll stick step text in there. And now we're going to find that step name str is not used, so we can get rid of that. And then we're going to find other things aren't used, or have we used those things elsewhere? We've used them elsewhere. The step name itself gets used to create modules and all sorts of things. So we're closer. Now, if we run this build, we ought to fail to compile. And we'll fail to compile because every single one of these steps is calling subplot lib step : new incorrectly, because it's not being given arguments to build. And how are we going to work that out? Well, the actual call to build comes from the way that we construct our arguments in the template. Let's go and have a look at the Rust template. This It's in the macro. So this is how we do a step construction. We call the builder default, we supply all of the arguments, and then we call .build. And that's how we construct a step function. So this here needs to be given something that is the text of the whole step. So a useful thing to do would be to look at how this is done in the Python library. Let's have a look there. Template.py here. So here, self scenario set title, scenario title. And that says scenario title. My guess is scenario.title in our templates is equal to the full text of the scenario. And if we go and look here, we never use that when we come and decode everything. You know, we have the step that we've called this with. And if we go ahead and look at how we're calling it, we have fn scenario title turned into a name slug. And if we go ahead and look here, then do we get told it's in this particular function in any of these? No, we don't. But we do get told the name of the output file. And if we go ahead and look at this output file, then you can see, you know, we have fn install subplot. If I search for, what's the name of the scenario that we've been playing with up until now? The name of the scenario we've been playing with up until now is no date anywhere. No date anywhere. We can see there's that title that's been slugified. And you can see here, you know, let step equal create the builder, embed the file into it, and build, and then add the step to the scenario. So all we're trying to do is we're trying to change this to use scenario title, and we need to be able to decode it usefully. Now we have a base 64 decode function, which we deliberately use for this kind of thing. And that decodes a string into, I think, basically a byte sequence, which is not ideal. So we're not actually going to use that one. What we're going to use instead is a basic escaping function. So we don't need that open anymore. We don't need that open anymore. All we want here is we need the scenario. How are we calling this in order to invoke it? We do for step in scenario steps, call the builder, passing the function and the step in. So we need the steps title. We've given the scenarios title, actually. We need the steps title. How do we get that out? We create a step. We set its kind. We set its text. And then we set the arguments. Aha! So we have step.kind, which will be a basic string. We have step.text, which will be a basic string. And we want to put that into our output. So let's do a really, really dodgy thing of just going, it's that and then that. And that one is going to be, how do we just insert something? It's brace, step.kind, and brace, step.text. What's the likelihood that that's going to work? Pretty low, but, you know, we'll give it a go. So we run cargo test. That's going to end up rebuilding a bunch of stuff. Right, so the problem with that is that, number one, we still need to lowercase it, and number two, it's not a string yet. So how did Python do that? Python piped it through lower, so that's a good start. So let's pipe it through lower. And then the other thing we want to do is we want to get that out as an escaped string in double quotes. The Python code just goes ahead and single quotes it because it can be fairly confident that life is good. For step.kind, I think we can trust that because that's actually an enum within Subplot. But for the step text, what's actually happening in the Python code is that it's getting base 64 encoded and then passed through. And my problem with that is that our decode base 64 function is... Oh, it does output a string. Okay. Oh, that's much easier. I thought it output a byte sequence because it's a standard base64 code, but I must have intended it only for this kind of thing. So that's easy. That then is going to be another call to base64 decode, passing in step text passed through base64. And those should be double quotes, not single quotes, because this is Rust, and another bracket. So we'll save that, and we'll try and run again. And I think that's exactly what we were hoping for. Scenario no date anywhere, step, given file dateless, given that file has that modification time, given an installed subplot, and then here, cleanup, given an installed subplot. Everything there is behaving pretty much as the Python stuff does, except for these debug statements, which I'm okay with for now. So what have we ended up changing? We've ended up changing subplot lib, so that instead of expecting a function name as a string, it's instead expecting to be given a full string that is our scenario. We could probably clean up a little bit there and get rid of that borrow. Expect build. Where's our thing here? Build, instead of taking an ampersand str, should take a string object, so it can pass that string through fully. And then in step.rs, instead of taking a borrow str, it's going to take ownership of the step text that you give it, which means that we actually can get rid of that entire lump and just pass it straight in. And that means that we're not creating more objects than we need to and throwing them away. We're still not doing it perfectly, but we're doing a lot better. And let's just double check that we've not messed anything up. And we're good. So once again, let's have a look at what we've done. So subplot lib, what we've done is renamed step.name to step.stepText, made it take a whole string instead of a borrow str, and that's it. So let's make that in, make scenario step hold a full step text rather than just a function name. And what have we got left? We've got subplot lib derive. This is going to be make the builder output, so pass the step text in .build. And then we have changed the Rust template to pass in the step text to .build. And that's pretty much done everything that I was hoping to do for that particular subplot bug. So I'm going to get that pushed. And then before we actually file our merge request, I'll take a copy of that URL and go and pop it down ready. Not copy the URL. That's better. We're going to run /check, and this does a lot of things. So it will actually run every single test that we have in Subplot. It will also check formatting on things. It will check that I've not messed anything up. And clearly here we have. We've messed something up. So what's gone on here? .build was supplied 0 arguments but expected to be sent some. Scenario.rs, line 230. So there's a doc test that we haven't fixed. Let's do that. Scenario.rs. Right, and here it is. Here's a little example of creating and adding a step to a scenario. So this is run command run. So I'm going to go when I run subplot. No, when I run true. I think that's everything that we need for a run. Let's double check. Let's just grab the share common run command. Yeah, it's just when I run. So when I run true. That should hopefully fix that one. Let's do cargo test --doc -p subplot lib. See whether I've missed anything else. A few others. So run command join paths line 125. So we've got some code here, and we're getting the error. What? Oh, no, I'm just being mad. When I run true .toString, because obviously that's a constant, and we shouldn't do that. And we've also got step.rs line 25. Yep. When everything works is probably a good one for that. And let's just pop that in like that and yoink that down, because that's probably approximately how Rust format would format that. Let's retest that. That's doing well. Just check any doc testing in subplot lib derive. I don't think there will be any. No. So let's have a look. Make scenario step hold a full step text rather than just a function name. I think both of those changes apply directly to that. So we're going to git commit fix up that, both of those, git rebase -i auto squash origin main. That looks correct. Push that branch up. Okay. Again, before we run our merge request, we'll recheck. This is why I use check./check, because it does all sorts of things that I otherwise wouldn't have thought to double check before pushing. This is actually used in our CI as well. So even if you forget, the CI will catch it. But it's always nice if we can get all the way through without worrying too much. We've certainly got further than we did before. So this is Python running those scenarios, and it looks pretty good. And the same will happen when we run the Rust code. It'll just be hidden because, you know, we don't need to see it. In fact, I think it's possible that we've already run all of the scenarios for subplot.md. Because the Rust library can run it all in parallel, it takes much less time. Much less time. I'm going to assume at this point that we would have exploded because we've run all the different kinds of things. So let's come along here and say we're going to complete this. What is your MR4? In order to make the no capture output of running scenarios under Rust more pleasant to read, we have adjusted it to better match the Python runner's output. This includes needing to capture the steps text as part of the builder for the step. Closes 280. I personally have read and followed the contributing guidance. The MR has pipelines enabled, and there are no license concerns with this contribution. I'm going to pop it into our iteration because it is related to that iteration, and I'm going to create the merge request. So that's now running, and at some point, my friend Lars will be able to come across that, take a look and decide if he likes it or not, and we'll go from there. I didn't write any additional tests for this because at the moment we don't have tests which assert the shape of the output of running Rust scenarios, and part of that is just that, honestly, they would be quite restrictive. It would be asserting a bit of UI, and yes, nominally that's useful, but in practice it just wouldn't be something that we expect people to want to have explicitly byte for byte the same every time. What matters when you run CI is that you get success or failure out, not the exact format in which the scenario steps are described. Okay. We've completed that one. What was the next issue in the iteration? Scenario context should be able to be introspected for state. Let's have a look at that one. Okay, so we don't have a lot of text in the description, so let's go and have a look at what a scenario context is so that we can think about this some more. Let's check out main and create a fix branch for 262. So this is about the fact that Subplot's scenario context internally is a little bit awkward to debug, and so from step functions, if you wanted to go, oh, just show me everything that's in the context so I can work out what's going on, you can't. In Python, it's pretty easy because the context is a Python dict, and you can just dump that. And in fact, the Python step libraries do dump it at various points. But we can't just do that in Rust at the moment, and it's quite hard. I'm going to remove the actively discussed label because we have actually decided what we're going to do about it. I just forgot to do that when we were setting up the iteration last time. And now we're going to come in and see what we're doing. How is that pipeline doing, by the way? Let's just pull that up as well. We're doing some compilation. Okay. So, scenario context. In fact, let's start in the documentation. That would be a better place. Scenario context. Yoink. So this is a container for all scenario contexts. It allows running code within a given scenario context, and it looks like it's pretty small. In practice, it's just that these are the only two public functions. Scenario context itself is then handled internally in quite a complex way. So what we want to do is try to do our best with it. What I could do is I could do cargo document private items, and that will -p subplot lib. If I refresh this, we can now see everything that's actually going on inside scenario context. So this is useful because we're developing scenario context. Obviously, users of scenario context only get that with and that with mute. But we get to know that you can create a new one. I mean, it's not documented because it's just internal crap. The title for the scenario is held in the context. There is this register context type, which takes context element things. And that's all we've got. And in fact, we've seen context element over here in the with and with mute. So context element is the bit of the context that someone can define. So let's have a look at that. Context element is a trait. And that trait says you've got to be default, you've got to be send, and you've got to be tick static. And a context element will get called when it's created, when a scenario starts and stops, when a step starts, and when a step stops. And what this allows is it allows for context elements to basically hook into the activity that's going on in in the execution of a scenario. I'll give an example of this in use. Let's go and have a look at the datadir type. So datadir has a datadir inner, and datadir has context element. And when we create a datadir object, the inner is constructed by passing the scenario title into this build function. And that build function maps that scenario title down. That's effectively slugify. And then we create a temporary directory by using a prefix of subplot, a suffix of that safe title, some 5 random bytes, and we make a tempdir. That tempdir object, when this context is finally thrown away, will get deleted. So that's great. We've got everything we need for run command. And we have a to-do here, which is that it would be nice if, under certain circumstances, every step we take a copy of the datadir, so that if a scenario fails, you can look at how the datadir has changed across the scenario. At the moment, we don't support that. It is a feature that I believe that the Python library supports for run command, so we may have to add that in the future, but we're not here to do that right now. What we're here to do is to decide whether it's reasonable to add a print your data method here, or whether we should say, okay, context elements should be debug, or maybe context elements should be display. And having that decision is something that I think we're going to do together. It's not something that Lars and I would sit and try to talk about, because frankly, it's not something that Lars particularly cares about, as long as he can debug his steps. What scenario contexts do we currently have? That's probably a good starting point. So we have the run command one. Datadir inner, importantly, these do not currently derive default or, they do not currently derive display or debug. It might. I don't know if tempdir does. Let's have a look at what it's 4 implementations. So tempdir implements debug. It doesn't implement display. So debug is likely to be closer to something that we could expect to come out of this. What about the files thing? Do we have a context for files? So we have this struct. We have a context element for it. It contains a hash map of strings to metadata. Metadata is just information about files. And the reason that this exists is because there are scenario steps that can remember and compare file metadata. So this is that memory, effectively. And the reason it's strings rather than path buffs is because ultimately all scenario input in Subplot are UTF-8 markdown documents. So it's completely reasonable to expect it to be a string. The run command library, what has that got in it? It has a hash map of OS string to OS string. OS string almost certainly doesn't implement display. Does it implement debug? Oh, goodness me, that's a big mess. Let's just go and have a look. Run command, OS string. Do we have an implementation of debug? We have a lot of implements here. Yes, we do have an impl debug for OS string. So again, we could almost certainly debug this. Debugging for run command is going to be a bit of a mess, because realistically, rather than treating stdout and std as vecu8 at this point, we probably want to treat them as almost certainly UTF-8 strings, because debugging goes along that line. So we'd probably want to manually impl debug for run command. Do we have any other step contexts in play? I don't think so. I think that's all of them. I think some of the testing code might deliberately create some contexts just as examples, but it should be reasonably easy to ensure that they are debug as well. So why don't we make the step, if you'll pardon the pun, of saying that scenario context element type has got to be debug. If we do that, we're getting a chunk of the way there. But can we then make scenario context itself debug? And the question basically comes, the container object, can that be debug? Let's go and have a little look. Oh, nope, that's useless. Let's search for container. So, containers, trait implementation debug, impl, k-kind debug for container k. All that tells us is the size of the container. That's a bit sad. Is there anything in here that lets us retrieve all of the elements one by one? Container get, try get, with map. Container kind send. I don't think so. So we're going to have to think a little bit more carefully about this. Do we have a way to enumerate all of the stuff? And I think we do. I think it's these hooks. And the reason I'm saying that is because when we create the scenario context and we register a context type with it, we try and get the scenario context item for that context type. If we didn't get one, then we do quite a bit of work. And that quite a bit of work is that we create a scenario context item, which is a mutex accesses that context type. And the reason that we have to mutex it is because there is distinctly the possibility that you might have multiple threads, particularly when you're testing Rust code. So we want to be completely safe with that. And so we set that value in, and then we go, we're going to create a new scenario context hook object for the scenario context type. And the reason that we do all of that is because then this implementation starts to work. So scenario context hook kind is an internal trait that connects scenario contexts into the system. And you can see we mirror scenario start, stop, step start, step stop. The only thing that we don't mirror here is the created function. And I'm just trying to think whether we call that. We call that basically when we register the context type if we actually create it. So the point here is that that can give you some initial setup time. And we don't need that for the hooks themselves. But we might need debug for the hooks. And the reason that we might need debug for the hooks is because that way we can get the type, we'll therefore have monomorphized against that context type, and thus we can do the debug print at that point. This is not public. You can tell that because it's not pub trait. So what are we going to do? We're going to start by requiring that scenario contexts, these context elements themselves, are debug. So they need to be default, they need to be send, they need to not have any special lifetimes in them, which is what plus tick static does, and they need to be debug. Debug comes before default. This is maybe going to succeed, maybe going to fail horribly. It's going to fail horribly, and the reason is that that probably needs to be imported. Yes, it does. Let's... what's going on here? Consider importing... let's use stud format because that's the kind that I want. And now all of our step libraries have exploded because they're not debug. And we can derive debug for that. And we can... Shall we derive debug? No. So our inner is fine. You know, it will, by the time we debug this, almost certainly be in existence. And we don't really want a sum wrapped around it because that's pretty ugly. So let's derive debug on datadir inner, but let's impl debug for datadir. Get our missing elements in. And the way that we want to do this will be either we're empty or we're not empty. And the way that we're going to determine that is we're going to match self.inner get our two arms, sum inner. Now let's just borrow that to make sure that we don't mess anything up. So the none is going to be I'm debugging a struct, and it's going to be datadir, and the field name will be inner, and the value will be none. So we'll print the none out in that context. And in this context, we are going to do borrow self.inner as a borrow of debug dot format into f. So that's the pretty much the core. Either you're going to get datadir inner none, or you're going to get datadir inner with the content. It's not the prettiest of things, but I think it'll probably be better than not specifying that. So files, we may as well just derive debug. On files, there's no particular reason not to. For run command, we need to be a little bit more clever. So let's impl format debug for run command. Now, by default, that's what the debug implementation will look like. This is not ideal because the value that we pass into that field just has to be something that can be debugged, but it's this vec that we're not particularly interested in. So instead of passing in the borrow of the vec, we're going to pass in from UTF-8 lossy of all that, and from UTF-8 lossy of all that. What? Why is that missing? I'm pretty sure there's a from UTF-8 lossy. Oh, it's string : from UTF-8 lossy. Fair enough. And expects a borrow, so we'll give it that. And the reason that we want to do that is because otherwise we're just going to get a huge list of numbers rather than actually the useful thing, which is it's approximately this text that was output. So we're roughly in a position that everything works. Unused variable inner there, so we'll just, whatever. I mean, it's not the world's best match. Let's actually use inner and do that. Okay, we're halfway there. And the reason I say we're halfway there is because all we've done at the moment is made it possible to debug stuff. Now we get to actually work out what's going on. So we ran cargo build, and the problem that it found was that subplotlib.rs is implementing a context element. And that's basically this function here. And the reason that we have this is because to work with subplotlib, you need to be able to install subplot. There's a bunch of other bits and bobs. And we have a subplot context which doesn't implement debug. Let's just stick debug in there and let's rerun check. It gone boom. What's going on now? The sequence example doesn't do it. SEQ, seek extras.rs. Do we have a context object in here? I don't think we do. Oh no, we were still building subplot lib. Did we not rebuild that file? Counter files usize. Oh, subplot lib itself. Silly moo, Daniel. Must have some helpers. Subplot lib context, it does. There we go. Let's stick a debug impl on that. We're getting further. So what we know now is that every context implements debug, which we will now be able to use. So, what a surprise, things aren't great. What's missing in... Ooh, Prelude. That's fascinating. Have we got a whole bunch of doc strings that muck about with contexts? What are they on? Prelude.rs, prelude : step, line 73. Ha! Oddly enough, we have a whole bunch of example code here that we need to stick the debugs in, otherwise the context examples don't work. It's good, you see. We find all these situations with ./check that we wouldn't have otherwise because subplotlib was compiling. Assuming we get... No, we didn't get through context element for some context type. Line 73 would have been helpful if I'd actually paid attention to the line numbers, wouldn't it? Once this works, we need to work out how we're going to implement debug for the scenario context object itself, because that's the one that someone is going to try and debug print in their step. Source file.rs. Yep, that's fair. Import context element. There's only one in there. It's good, isn't it? I could probably run at this point cargo doc cargo test all doc. That might be slightly faster for finding these, but we might actually need to find other things elsewhere. Right, so we're actually successfully running some subplot tests now. So at this point, I'm going to close all of these files out, and we can probably make a commit. Do I want to let that continue? I'll let that continue, and we'll talk a little bit about what we're going to do here, although we're not actually going to implement it yet. So context element now implements debug, which means that scenario context hook kind, we could add an fn debug that takes self and returns a... Well, takes self, takes a formatter, and returns a format result. And then we could work from there. So perhaps we should do that. And then we can implement debug for scenario context to print out the title. And then for each hook in the hooks, print out the fact that the hook exists and its debug output from internally. We're almost done with these tests, I think. Yep, they all worked. So let's have a look at what we've done so far. Mostly we've forced debug into all of the places that we want it. So subplot lib, ensure that all context elements import objects implement debug. So that's our first step. Next step is to add the debug thing here. Produce your debug output fn debug, which takes a self. It takes a format formatter, and I think what it actually takes is an f, which is a borrow mute format formatter, and it returns a format result. Now, this impl is missing, so let's yoink our missing member in. And the way that we do this is we're going to do context.with_mute of C, which is no, we don't need a with mute. We can do a with of C, which is a borrow of C. Borrow C as borrow din debug dot format f. Oh, we need to be given the context. Silly me. Of course we do. So that comes in as an argument there. And there. This function takes 2 arguments. It does indeed. It needs a true because we don't care about poison. And what's our error now? Mismatched types. Expected, a format error. Found, an arbitrary error. And that's fair because with gives you back a step error. So that's not ideal. How can we make that better? We could have an internal with that doesn't try to change the error type. So with looks like this. And we want to force step error for almost everything that gets used normally, because otherwise we get extremely confused. But we could have with generic, which takes an error type as well and returns a result error, and the function that you give it gives you a result error. And rather than calling with mute on that, we're going to have to call with mute generic. And with mute generic doesn't exist. But if we say with mute generic is that, how do I stick the E there, and we get the E here, and then we go, okay, so with calls with mute generic like that. How bad is this? Oh, right. So, yeah, we're not going to be able to do it like that because ultimately we need to be able to return different kinds of errors out. So with generic is going to have to give us back an option over the whole thing. No, that's not good. We'll just do it ourselves. And that means that with generic, we're not going to pass diffuse poison because we're always going to diffuse poison. And so what we want to do is say effectively this. And our function, rather than taking a borrow C, is going to take an option of a borrow of C. That's good. Because that way, if there's no element there, it'll get a none, and that's much more sensible. So rather than try get OK or blah, we're going to stick a semicolon there, and you're going to have an option scenario context item. Doobie-doo. We're then going to acquire the lock and then call a function on that. So let's do that. So let's say what are we going to do for this? We're going to go how? Oh, I know. Yeah, lock is psi.map given psi match psi.0.lock blah 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 blah. Except there's no if defuse poison. It's definitely happening. And then we pass lock straight in. So what we have here is expected an option borrow C, found an option mutex guard as deref. We're getting closer. So with generic, I'm going to make not public because I don't want other people calling this. It's a little bit of an awkward function. So we'll stick with generic on there. We can get rid of the comma true. And what's that? Type mismatch enclosure. Expected signature of thingy. Yes. So C is an option borrow C at this point. Now, the thing about this is it's going to print out that scenario context element as a none, which is not terribly exciting. What I'd rather is that it printed out nothing at all or gave back nothing at all. So I think what I'm going to do is I'm going to go option of format result. And this seems a bit weird, but you know, it's the way we go. It's kind of how we roll. And we're going to say c.map given c, run that. Method debug has an incompatible type for trait. Expected function pointer. Yep. Stick option there. Expected a result, found an option of a result. Really? Oh, because with generic is meant to return a result object. Gosh darn it. Get rid of that cleverness. For now, we're going to take the sum. You know, it will work. It won't be pretty. Now we need to implement debug for scenario context. Title, definitely want inner. Not terribly interesting. Hooks, we don't want to print like that. We want to start messing about. So we need to understand what a formatter looks like. Docs.rs. Formatter. So we've been calling .field, haven't we? And .field gives you a thing. So could we do dot debug struct. No, we could do dot field of something, and that something is any title and a impl debug. Debug tuple, debug list. So debug list gives you a thing where you call either .entry, or you call .entries and give it an iterator. This is perfect. Yes. So can we give the list a name when we add the debug? No. Debugging a set, debugging a map. If we did debug a map, then we could do name of the scenario context kind. Do we know that off by heart? No, and debug will show that anyway. So realistically, we want to debug list, but we want to do it inside a field. How can we do that? How can we do that? So dot field do we not have an FN for that? I don't understand. Oh, it's because it's inside debug struct. So that's a debug struct object. Here we go. So dot field takes a name and a value and gives you that. Finish non-exhaustive, finish, and we're done. And dot field takes a borrowed in debug, and it's going to call debug on it. So what we might have to do is create a list. What else could we do? I mean, we could just do the entire thing as a vec and then borrow it. So we could go contexts as the field name, and then we could borrow something that's going to be a vector of stuff, and we could create that vector here. So let's do that. What happens if we say, okay, so let inners... Oh no, because it's expecting an impl debug, and we weren't going to do an impl debug. Ah! Borrowed in debug. I think we're going to have to make our thing here, instead of taking the formatter in, it's going to have to return out the thing. So rather than a format result, it's going to return a borrow din debug. And we're going to have to tie that explicitly to the scenario context lifetime. Otherwise, the compiler won't know how that's working. So I'm just going to get rid of those entirely and ask Rust Analyzer to give me that missing member. And that's going to be contexts.with a generic, given a C, which is an option of a borrow C. We're just going to do I'm not sure that's going to work. I mean, you can't... A step can't get hold of the scenario context object until it's running. The scenario context object can't have anything inserted into it that hasn't been created. So at no point, realistically, should this be able to be anything other than a borrow C. I'm going to make that assertion. I'm going to say that's definitely the case. And so here, while we have an option, it's not what we want. We're just going to get rid of that map entirely. We're going to pass a borrow of the... Oh shit, it's inside a mutex. We're looking too deep here. I don't think this is going to work. Let's get back to it takes an option and the formatter. And think again. So, at this point, our difficulty basically is how on earth do we create a thing which is essentially a list of all of the debuggables out of the scenario context? Because I don't think we can. But what we might be able to do is create a type which is a debug for this stuff. I think realistically we can get rid of the option here and we can expect scenario context item not initialized. And we've got rid of that map. And so we don't need an as deref there. We want to just do that. And we can keep going with making this stuff as simple as we can. Doesn't take an option. It takes a borrow of C. And here, that doesn't take an option. It takes a borrow of C. And therefore, we don't need to borrow C there. We're getting a bit closer to where we need to be. What we need is to complete this formatting nicely. So what happens if we create an object that can represent attempting to debug a given element from within the context, and then we go from there? Yes. Okay. Is a debug list, which, you know, realistically, what to work that? Oh, actually, that takes a borrow mute self. Can I create a formatter from a formatter? Is there a clone? Doesn't look like there's a clone. So alternate determines if the hash flag was specified. I think that's the only thing that we care about for debug, is that we need to debug with the hash. Although there's also all of these sign related things that realistically we should support. So what's flags? Use sign plus, sign minus, alternate, or sign aware zero pad methods instead. What form of alignment was requested? Formatting debug, I think, doesn't do a lot of these things. Let's have a look. Format macro. Format args. Use the format arguments in debugging display context. Shows the debugging display format, blah, blah, blah. So we've got that. I don't think we're going to get to see the format args macro. I think it's an internal one. Yeah. So I think we just get told, effectively, we're in debug. We either have the alternate mode or not. So we could probably use that to our advantage in creating a list of objects that represent the result of debugging our scenario contexts. So let's do that. Let's say that we have a struct debugged hook, or debugged context object, which just contains a body, which will be a string. And we can import for debugged context object fn new, which is given a c. So object borrow c goes to what are we going to go with? We're going to go with goes with a self, and it doesn't just take that, it takes alternate as a boolean. If alternate go let body equals format object, else format object self body, and we can go where c colon debug. So we're about halfway there. That creates it. Now we want to import debug for debugged context object. And in here, we're just going to not even do f.debugStruct, we're just going to go f.write str. Maybe we should, maybe we shouldn't. Well, let's just try this. f.write str of self.body. So we're getting a bit closer. Next step, for all of those contexts, we need a context. And that's going to be... Oh, no, now we need a vector of these things. Or we could have a debugged context object. Which, Debugged context. See, we're going somewhere else. That's going to be a vec of strings. We're going to say we're going to add into self this thing. And it's going to be self.body.push body. And we're going to derive default on that. Debugged context. We're then going to import debug for debugged context. Wow, we're getting somewhere. Okay. And this is going to be f.debuglist.entries. And we need an iterator here, so it's going to be self.body.in.iter.map given an s. We're meant to return something that is debuggable. Entries, yep, needs a thing that's impulse debug. So it's going to be a debug context string of s, and then we'll finish. And we have a struct debug context string given tick A, which just has a borrow tick A str inside it. Doesn't implement debug, which is correct. Impl debug for debug context string f.write str self.0. Impl over tick underscore for that. No, impl tick A for that. We're getting somewhere. We now have that, so we need to create a debugged context. So we're going to go let mute context equals debugged context default for hook in hooks dot iter. Is it that, or is it hooks.get.iter? How do we get into the hooks? Let's look at our run function. Hooks.borrow.iter.enumerate. Okay. We're just going to do hooks.borrow.iter. And here we've got a scenario hook kind. And what we want to do is debug print that into our thing. And we can do that by getting a... So we've got our debug function. And rather than taking an f borrow mute formatter, it's going to take a c borrow mute debugged context and an alternate bool. So let's once again clear that out and do that. And it's going to be context dot with generic given a c, which is a borrow c. We're going, and let's say that's a DC, just so that I'm not getting very confused. DC.add takes C and alternate. And if I just do OK around that whole thing, that really should work. Type annotations needed, cannot infer type for parameter E on the exit. Ah, yes, we don't know. Should we just make with generic not return a result? I think that's nicer. I mean, after all, it's just, you know, a really, really scraggy thing. So we don't need an R and an E, because in fact we expect to return nothing. And it's an FN wants to unit. Unneeded unit return type. We're getting closer. No method named unwrap on that. Okay. So we now have our iterator here. And in our iterator, we are going to call hook.debug, passing it our scenario context, which is self dot, which is self, idiot. We're going to pass it our debug contexts, and we're going to pass it whether or not we're in alternate mode. That creates our debugged context thing. And then here, all we need to do is pass in that. Woo! Okay. We've reached a point that things aren't exploding again. So let's do another check. So at this point, what we have, assuming that all of this passes, is we have an implementation of debug for scenario context, which is the thing that we want. And in that, we'll output the title and we'll output the contexts. That's going to be output as a list where each entry is just a plain string output from attempting to format that thing. And this function here is how we attempt to format it. And we attempt to format it using this, which comes in through here. It's almost certainly an easier way to do this, but I'm not necessarily an expert on debug, so this will do for now. Someone somewhere will come along and go, this is an enormous mess. Look, here's a tiny little function that will do it. But for now, the problem that we have is that we need to be able to indirect through those mutex locks, and that just makes it super hard to debug that particular entry properly. That's going pretty well. So while that goes, let's have a little look in here and see if we have any context that takes scenario context. We do. So install subplot explicitly takes a scenario context object. So we could, in this step, deliberately output, because we see the creating temporary rundir, we've seen that happen in our code. What we might want to do is handle that further. That all passed, good. So let's just come in here and we can go, I don't know, print line, context, boop, context. It's pretty simple. And if we do that no capture for no date anywhere that we were doing before, we need to regenerate the source code. So at the moment, we have this slight problem that the scenarios aren't always regenerated. Scenario context starts, no date anywhere. Here we go. So there's that scenario context object. It's ugly as sin, but this is Rust, so we can stick a hash in there. And if we do that, make sure that we've regenerated the tests. Come on. Right, we've definitely regenerated the tests now. Now, here's our scenario context. You know, there's no date anywhere. That's fine. That's the title. And in the context, we have a data inner that looks like that, a subplot context that looks like that, a run command context that looks like that with those convenient little empty strings. And that's all looking good. I declare that a success. So let's get rid of that line from there because we don't want it. So subplot lib, make scenario context, implement debug. Like I say, that was a pretty gnarly bit of code, and there's almost certainly a better way of doing it, but that's the way I'm doing it for now. Let's just double check that that's going to meet. Oh, we've got a green tick there, so that's great. Hopefully Lars will pick that up soon. Is this going to meet this requirement? Might be good to do as a debug impl or else some other call, blah, blah, blah. Well, we've successfully implemented a debug impl against that thing, so let's push that up, which is going to make a new branch. And let's go ahead and add that. So, description. we require that context element is now debug, and in doing so make it possible to debug print scenario context. It's all a bit gnarly, but it's the best I could do given all the indirection through the container and mutex objects necessary to keep the scenario context safe. Closes 262. And once again, I know I've read that, I know that the pipeline will run, and I know that there's no license concerns. Again, that's going to be in this iteration. Let's create that merge request. I mean, it's quite possible that pipeline will fail, but we are where we are at this point. I'm going to take a very short break. I'll be back in a few minutes and we'll carry on and have a look maybe at some Rustup stuff. I think I need some please hold music. Okay, let's get back into things. So, what are we going to look at next? We are going to look at Rustup. Let's actually look at Rustup rather than someone called Rustup. Okay, let's clear down that editor. It's not that interesting anymore. Let's come into Rustup and let's get any changes. Okie dokie. Not origin master. Rustup master. Good. Okay. Let's just go user settings Workspace. No, it's editor. Zoom. Window.zoom level. There we go. That's going to be a 2. Unable to write settings because internal error. Great. Yes. All I wanted was to avoid seeing that complaint about setting size not changing, but never mind. Okay. So Rustup, what do I want to do? Well, what I was thinking is this issue here looks to be moderately simple to do, and it's been a couple of weeks and no one has turned up and said they want to implement it, but people have talked about it. So it's been mentioned in all sorts of places, including other commands. So let's have a go at doing this. So profile empty could be useful for a number of users, and we could add it now. I mean, in reality, we can make a draft PR. I'm not going to make a full PR for this because I'm not sure that we have time. I'd quite like to finish in 20 minutes to half an hour. So let's have a go. So this is 2970. Let's make a branch. And step 1 is to find out about profile. Do we have anything talking about profile in here? No. So let's be case sensitive. And let's look for, I think it's an enum. So it's in source dist. Okay. So let's come back here. dist.rs or just source dist. Probably here. Right. So we have an enum for profile which has minimal, default, and complete. We can also stick empty in here. We need a name match, so empty or E is going to go there. Names, empty, minimal, default, and complete. And the default is obviously default. So there's a start. We have created that profile. Now, where are we here? Missing a match arm. Okay, so we've not broken anything too hard yet. Now, the big question basically comes, what happens if we try to use this? And so what we'd like to do is we'd like to write a test that shows that when we use -- profile empty, we don't get any components installed. We only get the channel, basically. So the toolchain exists, but it's got no components in it. So how do we achieve a test for that? Well, Clive v2 seems like a reasonable spot to put it. Let's go right the way down to the bottom. And let's go, we want to write a test, and that test is going to be 2970. So we're going to test empty profile can be installed. And we'll set up with a config. So the way that Rustup's tests work, we have this setup function. That setup function basically creates a fake Rustup server installation, and then installs just the Rustup binary that we can then use to install toolchains. So for example here, Rustup toolchain install, profile minimal, nightly, component, rust source, and we would expect that rust source is present. So let's have a go at saying I'd like nightly, but I'd like the empty profile. So first of all, we can expect it to be okay if we ask for Rustup toolchain install profile empty nightly. That should succeed in and of itself. The next question is, how can we tell that there was no installation? How can we tell that you know, nothing has been installed? And one way that we could do that is we could look at the output of Rustup component list. If I run that here, toolchain stable, you can see there's an awful lot of stuff displayed. But if I say I only want to list the installed components, then we get a list. So in theory, if we say Rustup component list installed toolchain nightly, we should get an empty string. So we can say, oopsie, not there. In theory, there should be no installed components, but the toolchain should be present. And we can test what happens if we have a toolchain that isn't present. If we call it Shabert, then we get an error and we exit. So expect OK is not going to work. So expect OK stood out. Okay. Now cli-exact tests exact output from the command line, and it has therefore all sorts of bits and bobs, and it uses expect OK ex and passes a specific stood out and std. So we're going to use that. We're going to use expect OK ex, which takes config. It takes some arguments. It's going to be Rustup component list installed toolchain nightly. And the stood out that we expect should be exactly the empty string, and the std we expect should be exactly the empty string. So now we want to run just that test. So we're going to go cargo run, cargo test --test cli v2 -- exact that. And now we find out whether or not it works, or if something horrible goes wrong. Running that one test, something went wrong. Okay, so what happened? We ran some code, we set auto update mode to disabled, and we had this error, profile not found, empty. So we can't just say, hey, we've created a whole new profile and we've just not told it anything about it, because when it tries to look that profile up in the toolchain, it can't find it, and that's a problem. So let's now go and try and find that error. So that was a profile not found. So that's in source dist manifest. Doobie-doo here. So profile not found occurs at this point. We expect to be able to get the profile from this hash map of profiles, which is self.profiles, and then that should give us a component list. So if profiles is empty, we go an old manifest and we get the legacy components. And this is get profile components. What's calling get profile components? So that's doing profile default. That's doing profile default. If it looks like a V1, it doesn't matter what profile you specify. You always get the default components. There's no choice. And here's where we actually determine the set of components that we want to install. So in here, we match profile. If we've been given a profile, we fetch the profile components. Otherwise, we give vec new, which is just an empty list of components. So if we swapped those two over and we said if it was some profile empty or none, then we get the vec new out. In theory, that should work. Let's find out. Let's run that test. We've not changed the behavior of the none. All we've done is we've said that some empty should behave like there was no profile. Did that work? This tells us that the toolchain is not installable. So that's clearly not what we're meant to do. Why would it say that the toolchain is not installable if the component list was empty? So the error message is toolchain blah is not installable. Okay, so that comes from errors.rs. Let's have a little look at that. So is not installable is toolchain not installable. And that's the only place that that comes from. So not toolchain exists. So basically, when we tried to install no components, we got nowhere. It just went, there's nothing to do here. And that's what we want to find out what's going on. So blah, 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 blah. Final check to ensure we're installed. If not, toolchain exists. Toolchain not installable. Nightly. So the toolchain didn't actually get installed when we tried to install it. It syncs the channel. It got the content, and then it failed to install. So we're supposed to install this toolchain object. That says if it exists, we get its old Rust-C version, otherwise none. Then we say we're updating it, or we're installing it, fair enough. We then run against that. So this is install method. An install method run goes, okay, we're going to be doing, in this context, a dist operation. And that one calls update from dist. Update from dist ends up calling into here, update from dist underscore. That's the thing that goes, okay, let me fetch the object. So try update. That downloads the manifest. Then we have this determine the set of components to install. So we have the profile components, which we've inserted into all components. We then, for the components in the list that we've been told to install, which will be empty, we add other components. For the target, in the targets we've been told to install, we add the other components. The explicit add components is therefore going to be empty. The changes is therefore empty add, empty remove. And then we call manifestation update. This function updates. So what do? We call build update on the operation, and if nothing changes, which is essentially the thing of saying, okay, well, you asked me to install this component, but there's literally nothing to do, then we are unchanged. And my guess is this is what we're hitting and then failing to get anywhere. So let's just stick a quick eprintln nothing changes and rerun the test. I can almost guarantee that's what we're hitting. Is it? Yep. Nothing changes. Oh, it's auto self-update set to default, nothing changes. And then so Rustup toolchain install profile empty nightly. Didn't say nothing changes. Interesting. So the nothing changes was there. And that is just the part of the setup where we say there's nothing to do here. Auto self-update mode is disabled. So we're not hitting that code. I wonder if I can eprintln, see if update is debug. Because I'm interested in seeing what the update object says about this process. Did anything happen then? Okay, so we're not even getting into that function. You know, here we can see that there was no update to occur. But here, we're not even actually entering this update function. So let's go back to dist, which ended up calling manifestation update. How could we early exit out of this? Let's get back up to here. So an empty profile sets profile components to be empty. That means all components will be empty. We've got no components to add, so it's still empty. We've got no target to add, so it's still empty. Explicit add components is therefore empty. I mean, are we even reaching here? Let's see whether we are. This kind of debugging is painful, shall we say. Rustup's core is very twisty-turny. Nope. We didn't get there. Something somewhere must have decided that that profile doesn't exist. Let's just double check. Let's go. Looking for profile. My guess is that that's not going to have output anything. So that we had looking for profile sum empty. Nothing happening. That's interesting. Am I just looking in the wrong place in our debug output? So that's attempt to install nightly, and this is attempt to list components. Let's just double check that we're not looking in the wrong place. Don't think we are, but we might be. Attempting to install nightly. Looking for profile, blah, blah. Oh, we ran that in process, which is why that's turning up there. And then this is what's actually coming out. Because the infos and the errors and so on actually get written properly to the in-process handler. So we are actually hitting what I thought we were hitting. I was just being crap about determining that that was where we were. Let's get rid of the extra debug that we don't need. So what we want to say here is I don't care that there's nothing to do. We do actually still need to achieve the installation of the toolchain. And so that probably needs to come down by having force update? No. Changes needs to say we are requesting the empty profile. So let's find the changes object and let's say permit empty. Which is going to be a Boolean. And dist is therefore failing because okay, so permit empty is going to be profile is equal to profile empty. Can I not do that? Explicitly, we've passed in profile empty. And then in manifestation, no, in install, no. In manifestation update, there we go. If nothing changes and not config, no, and not changes dot permit empty. Now let's see whether that works. Where are we missing here? So when we're adding a component, we're not going to permit empty. And when we are removing a component, we're not going to permit empty. Because ultimately, this is not permitting an empty toolchain, it's about permitting an empty change set. So that when you try to install the empty profile, it works. So now we have a dis.rs bug, which is almost certainly that we're constructing a changes object here. Again, we're actually trying to test adding stuff here, so we don't want an empty operation. Let's give it another go. And that succeeded. So this allows us to create empty tool chains, and we can test that we can install the empty tool chain, and that therefore the empty tool chain is good. We should probably confirm that you can remove an empty tool chain, and that you can add components to an empty tool chain. So let's go for empty profile can be uninstalled. So we're going to expect OK. We don't need to pass those in. Rustup. Ooh, goodness me. Tool chain. Uninstall. Nightly. And now if instead of doing -- exact, we go for empty profile can as the prefix, we'll get to run both of those tests. And they both pass. And so the next step is that we can add a component, remove a component, and then the profile will be empty again. So this would be empty profile can manipulate components. And let's do this in stages. So we should be able to Rustup component add should be able to add the rustc component to the toolchain. I should then expect that that component will be listed. And it will be... Actually, let's add the Rust source component, because that component doesn't have the architecture labeled after it. So we should be able to... at this point, install, and we would expect to see Rust source new line. Install Rust source and check for it. And then we want to remove Rust source and check we are back to blank. And that should again bring us all the way back to that. Let's give that a go. Okay, so realistically, we've actually done the work that's necessary, but it's not necessarily ideal. And so what I'm going to do is I'm going to commit and push this to a branch, and then I'm going to invite someone else to use that as a reference point. But I will do that off stream because we have hit 2 hours, and that's about the limit of my voice. So thank you very much, anyone who's viewed it. And if you're viewing it after the fact, then thank you for coming in and being part of this. Good night.